Hi guys, yesterday we talked about the graphs and how to find the limits if we have the graph given. Today we are going to use different methods. One of them is going to be substitution to figure out what the limit is at the point. And if a function has no holes or asymptotes at the point where we are trying to find the limit, what we are going to do is we are going to take that point, plug it into the function, we are going to get a limit. Beautiful world. Let's take a look at example number 1. Limit as x goes to 3 of this function. Notice this one has some undefined values. Something is happening at x is equal to 2, but we do not care about point 2. We are looking for the limit as x is approaching 3. So the only thing that I am going to do is I am going to take 3, plug it in everywhere in place of x, which I already did. 3 squared minus 4 and 3 minus 2. This is the number that I did plug in place of x. And I am then performing all the nice operations. That is going to give me 9 minus 4, 3 minus 2, 5 over 1. Notice the limit is equivalent to 5. It is a beautiful numerical value. It is a unique solution. It is a limit at 3. Well, you are not going to work often with problems like those. Those are really, really nice, but again, it's not going to happen often. So let's take a look at example number 2. If I do the same thing that we did in the previous example, so if I will plug in 2 everywhere in place of x, what I am going to do is I'm going to get 2 squared minus 4, 2 minus 2. That's 4 minus 4, 0 over 0. Well, something like this is not going to work for us. We need a different technique. Okay, so remember, if you get 0 over 0, or as a matter of fact, if you get a number over 0, you need a different technique. So basically, you need to think about, is there anything I can do with this, this expression to simplify it? So let's take a look. I will continue writing here. I am still keeping this as limit. I am not going to plug anything into it. But what I do notice is that there's a difference of squares on the top of the fraction in our numerator. So instead of x squared minus 4, I can write this as x minus 2, x plus 2. Notice I am dividing it by x minus 2. Since I wrote this as factors, as multiplication, I can cancel x minus 2. And what this is happening is, this is taking care of this problematic term that once I did plug in the 2 into, was giving me 0. So now I am just going to rewrite this one more time. Limit as x goes to 2. Now I am only looking for x plus 2. And I can do exactly what I did in the first example, where I am plugging 2 inside in place of x. 2 plus 2, limit is equivalent to 4. I want you to think about this for a second. Think about this, how it looks graphically. This is a beautiful function that looks like a rational function. However, because this term x minus 2 cancels out, this would be one of those functions that is going to have a hole. So if you think of the functions that we discussed yesterday, this would be like one of those, okay? So what we did is, because we don't have a graph, we are looking at this algebraically, completely algebraically. All right, let's take a look at another one. This one, again, I am going to plug in 4. 4 squared is 16. 16 minus 4 is 12. 12 minus 12 is 0. 4 minus 4 is 0. I get 0 over 0. I have a problem here. So I need to do something. I need to think of any kind of operation I can do. So I am going to keep it as a limit as x approaching 4. Notice this is quadratic. I would hope that I can factor this quadratic expression so that one of the terms is going to cancel out with the 4. Well, I am going to use my x method because I like to. I am looking for two numbers that multiply to negative 12 and add up to negative 1. Those two numbers are negative 4 and positive 3. Again, I always check that multiplies and adds up. Okay, so now instead of writing x squared minus x minus 12, I am going to say x minus 4, x plus 3, and I'm going to divide it by x minus 4. I want you to see how convenient is that. So now I am only looking for the limit as x approaches 4 of x plus 3. And now I'm not going to be rewriting this one more time. This is equivalent to 7. So again, if you were to graph something like this, that would be a graph that would have a hole at 4. The point is not in the domain. However, you can still find the limit, and the limit would be 7. All right, let's take a look at another one. We're going to do a lot of examples today. I wrote them down for you. Again, you are responsible for the notes, so you need to copy them down and think about them once you copy them down. Again, the first thing, take the number, plug it in. 3 squared minus, so 3 squared 9 minus 9 is 0, 0 over 0. That is a problem. I need to do something. And what I am going to do is I am going to notice that this is a difference of squares. X plus 3, x minus 3, divided by x minus 3. Done. Now I can plug in 3. 3 plus 3 is equivalent to 6. Again, 3 does not belong to the domain of this function, but this is not a question right now. The question is, what is the limit? All right. Let's take a look at question number 5 because it looks interesting. I don't know if it's very interesting, but it looks funny. So I am looking for the limit as y approaches 4 of something like this. Well, this is like example number 4, it looks like, because 4 minus 1 is 3. Absolute value of 3 is 3, times 3 is 9. 9 over 7, done and done. There's no problem here. I was just able to plug in the number. Let's take a look at this one. Negative 1. What is going to happen once I plug in negative 1? I will have negative 1 squared plus 2 times negative 1 minus 8. I'm writing this down because I really want to avoid making mistake. Negative 1 squared plus, let's see, plus 5 times negative 1 plus 4. Let's see what happens. Notice when I plug in the numbers, I do not write the limit. But if I am working with the function, whatever the function was, I have to write the limit. So negative 1 squared, that's 1. 1 minus 2. 1 minus 2 is negative 1, negative 9. And then this is going to give me 1 minus 5 is negative 4 over 0. Notice, this is not allowed. We are not allowed to divide by 0. There's a problem with this. We have to try to do something about this. Now, I do see that both of those expressions are quadratic, so I can hope that they will factor, and I can hope that the factor that is giving me a problem is going to cancel out, and then I will be able to find the limit. All right, let's see. Let's find two numbers that multiply to negative 8 and add up to positive 2. Those two numbers are going to be 4 and negative 2. So limit as x goes to negative 1, I am going to have x plus 4, x minus 2. Notice we are using all the skills that my Algebra 1 class should be learning right now. And I'm going to do the same thing for the expression on the bottom. I'm looking for two numbers that multiply to 4 and add up to 5. The numbers are 4 and 1. I always check. X plus 4, x minus 1. Oh, look at this, something cancels out. However, it's not the one I would like to cancel out. What I do get here is that now, oh no, it's fine. Well, did I write something incorrectly? I did. This should be positive 1. It was positive 1, so x plus 4, x plus 1. Well, so now it is not going to work nicely, because if I plug in negative 1, so I'm just going to rewrite this so it's clear. X is going to negative infinity. I have x minus 2, x plus 1. There's nothing I can do with this expression. I cannot simplify it any farther. And if I plug in negative 1, I am going to get negative 3 over 0. And if you get to the point where you cannot simplify any farther and you still get expression that is 0 over 0 or a number over 0, the limit at the point does not exist. And if you think about this for a second, that means that this function has a vertical asymptote at x is equal to negative 1. So what happens with the y values, they are going to either positive infinity or negative infinity. I do not know how this graph looks exactly. We could draw it and we could decide, but I do know that the limit does not exist. So pay attention to those. Something like this may happen quite often. All right, let's take a look at another example. And we are going to use a different technique. And for this one, I am going to, well, I call this as I will get a common denominator. But basically, let's see what we get first once we plug in 0. So I will get 1 over 2 minus 1 over 2 over 0, which is 0 over 0, which again is a problem. So I'm going to get a common denominator, but basically the idea is that we want to simplify it. So we want to do anything and everything we can so that we change this expression to something else. So let's see. Now I am just writing this as a limit again. X is approaching 0. And I am going to clean it up. I am going to get the common denominator on the top of the fraction. And then we'll see where that brings us. So 1 over x plus 2 minus, well, the common denominator, I will multiply this by 2, and I am going to multiply this by x plus 2. So this is going to give me x plus 2. We need to be very careful because there's subtraction right there. And then we are going to divide it by x. We have to play with this one. So we will have 2 minus x plus 2, and I forgot to write the limit. My math teacher would say if you don't write the limit, this has absolutely no sense, and she would not give us any credit for the work. So you need to make sure you write this down. Limit, because my math teacher would say so. Limit x goes to 0, 2 minus x plus 2. Again, I'm trying not to make any mistakes here. I am not going to multiply it out quite yet. I don't know where we are going with this. So I have 2x plus 2. And this should be my main line. I promise I will write it nicer next time. This should be written a little bit lower. So when you make your own notes, make it nice. Let's see. 2 minus x minus 2. So what is going to happen, the 2 minus 2 is going to cancel out. So I only have negative x, but I do need to write the limit as x goes to 0. I will have negative x divided by 2x plus 2. And because I am dividing it by x, I am going to multiply it by the reciprocal, and reciprocal is 1 over x. Look at this one, how convenient. I can cross simplify this x and this x. Now, I am going to write down what I have because I want this to be clear. I have negative 1 over 2x plus 2. And now can we plug in 0? Let's see. 0 plus 2 is 2. 2 times 2 is 4. And negative 1 over 4 is my limit. So notice I wasn't able to find it at first, but then I did some magic and I was able to find it after. One more example together, we'll do together, and then I will give you some to practice. All right, so this method is, again, I call this as we are going to expand it. However, you don't have to give something like this a name. You can say, well, let's see. The first thing, always plug in the number. So 0 plus 4 is 4. 4 squared is 16. 16 minus 4 is 12. And 12 divided by 0 is a problem. So let's try to do something about this problem. And again, you don't have to call something, oh, I'm going to expand or I'm going to do this or that. Let's just perform whatever operations we are aware of. So I see that there's x plus 2 squared. Let's actually square it and hope for the best. X squared plus 8x plus 16 minus 4 divided by x. This is going to give me, let's see, limit as x goes to 0, x squared plus 8x plus 12 divided by x. And I wonder if I can factor this. However, I don't see how this is going to nicely simplify, but who knows. This would factor into two numbers that multiply to 12 and add up to 8, 6 and 2. X plus 6, x plus 2. And this is still division by 0. So I think the intention was that something should simplify nicely. But two things might have happened. I might have copied it incorrectly, or maybe it is meant not to work. Because here what I get is 6. 6 times 2 is 12. 12 over 0. So basically, if I keep doing this, does not exist. The limit does not exist unless I made a mistake somewhere. If you can find it and point it out to me, that would be great. All right, that's enough of examples for today. I just want to ask you to do this work, to do this in order. Again, this is fun. Mathematics is beautiful. Look at this, you're learning basically calculus right now. So take advantage of this time, spend it with mathematics, and please do the work. You guys, you've been doing really, really good. All right, and have an amazing day.